Hi everybody. So there are a few questions from the work that I assigned this week that tripped up quite a few people. So I'd like to go over a few select solutions of these problems. So the first one I'm going to do is from the course pack, page 5, number 3, this kite looking thing. We're asked to determine the length of AC. So if we can sketch that in. We want that. And there's a couple different ways to do this. I'm actually going to do both ways, just because I saw both and I saw attempts at both. So the first way we could do it, the first thing, that we need to notice either way is that this is symmetric. So our angle BCA is going to be the 58 degree angle divided by 2. So it's 58 divided by 2 is 29 degrees. Okay, so the first way that we're going to do this is finding AC in its entirety by noticing that it's the hypotenuse of the triangle ABC. I'm just looking at the top half of this. It doesn't matter, you could do the bottom half if you wanted to. So if AC is the hypotenuse of ABC, we could really use, we have this angle, right? I might as well draw it in, it's 29 degrees. So we need at least a side in order to solve for AC. We can get that by this triangle here. Right? So if we're looking at that triangle, it's got a 29 degree angle. What we're looking for is X. So if we knew BC, then we could determine the length of AC using that angle and trig. So the other thing that we know about this is that the side length is 4, which most of you got, since this whole thing from B to D is 8. Half of it is going to be 4. So we can solve for X using sine. So sine of 29 is equal to 4 over X. X therefore is equal to 4 over sine 29. That's 8.25. So this is going to be, okay, let's just redraw. Sorry, it looks kind of awful. Okay, so we know that the side length is 8.25. This is ABC. Right, we know that this angle is 29. AC, why don't we just call that Y to make it simple? We can use cosine. So cosine of 29 is, so the 8.25 is the side adjacent to the angle. Y is the hypotenuse, so it's 8.25 divided by Y. Y, using algebra, is 8.25 divided by cosine of 29. Plug that in your calculator and you get 9.4. Which is the answer. So that's one way to do it. I'm going to show you another way as well. One thing that, maybe I'll use another color. One thing that we could do instead is split this up into two triangles in a different way. So for example, this is the second way. I have to do it a little bit more compressed, I guess. So one thing that we could do instead is say, well, again, this is still going to be 29, right angle, 4. But we could split up AC into AE and EC and find them both separately and add them together. That's the second plan. So in this case, this is, thanks Siri. This is the side that we want. Let's call it X. We can find it using tangent, so tan of 29 is opposite, which is 4, over adjacent. X, therefore, is 4 over tan 29. which is 7.2. So that's EBC. We can also find, getting kind of small here, sorry. This is so far. This is triangle ABE. So if I found AE, I could just add them together. So let's call that Y. This angle here, though, that's a little bit of a mystery. We can find it though. So remember that this whole kite is we could do it very simply by doing the triangle ABC. You could do 180, take away 90. So hold on. Angle BA is equal to 180, take away our 90-degree angle, take away 29. That is going to be a 61-degree angle. So this will be 61. We'll use tangent again. So tan of 61 is equal to opposite over adjacent. Y is 4 over tan 61, which gives you 2.2. So this whole thing AC is equal to x plus y, which is 7.2 plus 2.2, which is 9.4, which gives you the same answer. So that's good. All right. Next question, the course pack, page 5, number 4. I had a lot of people get confused, like they solved for usually x correctly, but then used it in really weird ways. So I wanted to go over this quickly. So first of all, solving for x, again, which most of you did correctly, we could use sine. So sine of 29 is equal to opposite, which is x, over hypotenuse. In this case is 32 centimeter side. Okay, so x therefore is 32 times sine 29, which is 15.5 centimeters. Okay, so that's this 15.5. A lot of you ended up putting together equations where, or I guess trig ratios where you used 15.5 as the hypotenuse. Now 15.5 in this it's not the hypotenuse of anything. Okay, so the next thing we could do is find y. So we can look to find y, we can just look at this triangle here, DCB, and we can use tangent. So tan of 44 is equal to opposite, which is 15.5, divided by adjacent, which is y. Y therefore is 15.5 over tan of 44, and that is equal to 16 centimeters. And the question also asked to determine the measure of every angle. So a lot of you skipped that, and I know that these are practice problems, but on an evaluation, right, it's super important that you read the question and that you answer every part of the question. So if we were to solve for the angles, and this part isn't very hard, okay? So if we say solve for this angle, so angle DBC is going to be equal to, we can solve 180 minus our 90-degree angle minus the 44. That'll give you 46 degrees. Let's do angle ABC. That is going to be 180 if we're looking at the big triangle ABC. We'll do 180 minus 90, take away the 29. Right? That's going to give you a 61-degree angle. And if I also, so it's just find every angle. if I wanted to find angle ABD, so this little angle in here, I could just do angle ABC, so the bigger angle, take away the smaller angle. So that's just going to be 61, take away 46, which is 15. All right. That was this problem. We didn't have to solve for like AD, so, only do as much as the question asks you to. It's a good tip. Next question I want to go over is from the Trig applications worksheet number 14. So this, not too hard of a question. I just want to make sure that we are reading this correctly. So we're told that the lighthouse, maybe zoom in on it. This lighthouse is 20 meters. Oh my gosh, that's awful. This lighthouse is 20 meters tall, and it's on top of a 45-meter cliff, right? So that means that if we want to do this, make this a right triangle, right? This side length here is going to be 20 plus 45, which is 65. And remember that there are different ways to do this problem. I'm just going to do one way, but if you did something different, doesn't necessarily mean that it's wrong. It could just be different. So, all right, I'm looking to find the distance from X, from the base of the cliff to the boat. So that's X, it's the same X up here. So I can use tangent. Once you set up this problem, it's actually one step. So tan of 36 is equal to opposite 65 over adjacent X. X therefore is 65 over tan of 36. Plug that into your calculator and you get that X is 89.5 meters. All right, so a lot of you did this, but instead of 65, you used 45, but that's not the full, height of this triangle that we're given. All right, last question. Whew. A lot of you didn't even try this one, so let's spend a little bit of time with it. So we're looking for the height of the antenna. So you need to read the question to know what the antenna is, right? An observer is located at 0, so 0.0, and 40 meters away, so the distance from 0 to C is 40. So it measures the angles of elevation to the top of the tower. So A is the top of the tower, it says, and the top of the antenna is B. So we have two different angles, one for A, one for B. And we want the height of the antenna, so we want the measure of AB. All right? In order to find that, the only way, it's kind of weird, so the only way that we can do that is to find BC, so this whole height here, and subtract AC. All right, so I know this was hard, I think hard to visualize. So when you have things that overlap like this, or all these multiple triangle problems, it's not a bad idea to split them into individual triangles, because you have two, right? You have this triangle that has a 30-degree angle. This side length is 40. And so this is going to be your AC. And then you have another triangle. They look the same. They're pretty similar, I guess. 40 here. And this is going to be BCO. And we're looking for AC and we're looking for BC. Okay, so in both cases, the steps are very similar. So for this first triangle, we can use tangent. So tan of 30 is equal to opposite over adjacent. x therefore is 40 tan 30, which is 23.1. We're in meters, so let's write meters. Here, tan of 35 is y over opposite over adjacent, y over 40. Y is 40 tan 35, which, plug in your calculator, is 28 meters. So we haven't quite answered the question yet, just one more little step. To find AB, remember we're going to do BC, take away AC. So BC is y, right? AC is x. So we just take these two numbers, we subtract them. 28 take away 23.1. So the height of the antenna is going to be 4.9 meters.